If a machine gun forgives the shooter's mistakes instead of punishing them, it means it was designed correctly. This is the core logic behind the Kalashnikov machine gun. The Kalashnikov machine gun was not designed to break records or dominate specification charts. It was created as a stable element of an infantry fire system. It must function in conditions where ideal firing positions, regular maintenance, and precise temperature control are simply unavailable. For this reason, the design relies on generous mechanical tolerances, a long-stroke gas piston, and low sensitivity to dirt, wear, and harsh environments. The choice of the 7.62 by 54 rimmed cartridge immediately defined the role of the weapon. This is a full-power rifle cartridge with high impulse, strong ballistic performance, and reliable penetration behind cover. It shapes the machine gun not as an assault weapon, but as a tool for area control and long-range suppression. An effective firing distance of up to 1.5 kilometers is not about precision shots, but about pressure, denial of movement, and disruption of enemy actions. A major step in the evolution of the system was the modernized Kalashnikov machine gun. The primary goal of this modernization was to reduce weight while preserving the original operating mechanism. With a mass of approximately 7.5 kilograms without ammunition, the weapon became more mobile for the crew. The rate of fire remained at roughly 650 rounds per minute, a deliberate balance between fire density, controllability, and barrel service life. The modernized Kalashnikov machine gun retained a quick-change barrel, theoretically allowing sustained fire by replacing an overheated barrel. However, practical experience showed that in most situations, the barrel is either changed too late or not changed at all. As a result, the decisive factor is not the ability to replace the barrel, but how the weapon behaves as it heats up, especially in terms of dispersion and point-of-impact shift. This reality led to the development of the Pecheneg machine gun. While it retained the same operating system and cartridge, it introduced a fundamentally different approach to thermal management. Instead of a replaceable barrel, the Pecheneg uses a thick, non-replaceable barrel enclosed in a metal shroud. During firing, the shroud creates a directed airflow that distributes heat evenly along the barrel. The mass increased slightly, to approximately 8 kilograms, but this is the cost of predictability. The barrel heats more slowly, and more importantly, heats evenly. This reduces thermal distortion and minimizes shifts in the average point of impact. The Pecheneg is not designed for short bursts of extreme fire intensity. Its role is to hold a sector with stable, continuous fire. As a result, the Pecheneg becomes more than just a squad-level weapon. It serves as an anchor within a fire plan. It is especially effective in defensive positions, covering maneuvers and maintaining suppression without frequent cooling pauses. Stability takes priority over flexibility. What we see is a single design line shaped by real use, not theory. The modernized Kalashnikov machine gun increases mobility at the squad level. The Pecheneg shifts the focus to stability and controlled thermal behavior during sustained fire. Both solutions are built on the same core principles: a simple operating cycle, predictable behavior under continuous load, and tolerance to harsh conditions. There is no attempt to change the role of the machine gun, only to make it more controllable within that role. Here, effectiveness is not measured by novelty or specifications, but by how the weapon behaves after hundreds of rounds, when heat, fatigue, and time begin to matter. This is why the Kalashnikov machine gun lineage remains relevant, not because it evolves aggressively, but because it evolves correctly. It keeps doing the job it was designed to do.